time of this recording, I am the only one who has tested it. It works fine to me, as well in Windows and on Mac, so I decided to release Audio2Blender 0.1. This is Audio2Blender. With this add-on, you can sample any audio source in your system and generate values to use in geometry nodes in real time. So let's dive in. It's a regular Blender add-on, but to work it requires Python library called sound-device. And the easiest way to install it is through another add-on which is called Python Module Manager and lets you manage and install Python libraries inside Blender. Once you have installed Python Module Manager, you can easily install sound-device. Now you are ready to install Audio2Blender. In Windows you are probably ready to go, but in MacOS you need to start Blender from the terminal to get the privilege for the device's access. So let's test it. I can see my device. Let's start testing. Okay, you can see here the number is running and is reacting to my voice. Audio2Blender can work in two different ways. Volume mode, which is this, and it provides one attribute with one float value, or in FFT mode, where you can split the range of the spectrum that you choose in a number of bands. You have two kinds of sampling, linear or log. You can change them on the fly. Okay, now let's see how to access these attributes in Geometry Node. Select your device and start sampling. Okay, once you start sampling, a mesh object has been created. This object has an attribute, volume. So if you open your geometry nodes and your spreadsheet, you can already see the volume that run on a vertex in this mesh. So how to access it in geometry node? I'm going to create an object and a new geometry node. Drag the object volume and create a named attribute node with the volume attribute. Now we are going to sample the index of this vertex. Test, okay. Now you have your attribute value for the volume in geometry node. Okay, now let's be honest, it's super cool to scale a cube with the sound of your voice, but we both know what we are really thinking. Voice reactive Flappy Birds in Blender. Chip. Of course, you can mix real-time audio input with animation and simulation in geometry nodes. Here the bird is going up and down while tubes and clouds are moving. Chip. These are the nodes that handle physics for the main animation. We are back to our dancing cube and talk about FFT sampling. So stop and restart the sampling and create an FFT object, which is made of 8 vertices. Those vertices receive the attribute. The attribute for this object is just one, FFT, but is indexed on the number of the vertices that you create. Let's see what this means. Back to plane and stop the sampling, change the name in FFT, change the object in FFT, and now we have to sample not just one index but all the index that exist in this object, so those one, and let's create something to visualize what's happening here. Here is a simple line, curve line, resampled by 8. It is converted in a mesh like this, and in 8 instances we can set position the curve at this point and convert the value of our attributes in the Z value for our curve. Let's start. Okay, it's working. Okay, it's fine. Now we have 8 bands in this range, which is awesome. You probably noticed that the main activity happens here. So you can use FFT log for your sampling, and you can decrease the range. So maybe something like this could be enough. We can even go higher. Start 16, resample by this. Okay, you notice that there are some fail indexes. This is because there's not enough resolution for the log sampling. So what you can do is to double size this value, try, start and stop. Okay, better. Probably this is going to fail, but you have a very nice representation of a small range of frequencies in the audio spectrum. If you want to deal with this kind of thing, you can try to separate and trigger different parts from an audio. Think about a kick and a snare of a drum. This is Audio2Blender. It's just a beta software. Give it a try if you want and let me know about your experience in the comments. Bye.